Okay, here's sample problem 5.4. Calculate the amount of heat in kilojoules, kJ, right, required to heat 255 grams of water from 25.2 degrees Celsius to 90.5 degrees Celsius. Okay, it's water, and we're calculating heat. So we said that there's two equations you can use for calculating the heat transfer. So we're transferring heat to the water. So this is one. What was the other one? Remember it had a little bit different? It was capital C times delta T. And that capital C is called heat capacity. And the S is called specific heat. And what we said was that if you have a pure substance, like water or aluminum or alcohol, you can probably go ahead and use the specific heat. If it's a more complicated thing, like a machine or a shoe, then you would use the heat capacity. Well, this is pure substance. It's just pure water. It doesn't say it's liquid water, but the temperature is 25.2 degrees C, so that's probably liquid water. So we use the specific heat of water. So we're going to use this equation over here on the left. Okay? So the amount of heat required to heat water, W for water, would be the specific heat of water. Notice it's not given in the problem, but you can find that in the table in this section, right? And I also said, I think in the lecture, that if you're talking about water, that's one you might want to remember. You might want to remember the density of water, 1 gram per milliliter, and the specific heat of water, 4.184, or at least remember 4.18 joules per gram degree C. So specific heat, 4.184 joules per gram degree C, times the mass of the water. Now notice the specific heat is in grams, so the mass is also in grams. That's good. If the mass were in some other unit, we would probably want to convert it to grams. And then we're going to multiply that by the change in temperature. Now, change in temperature is final temperature minus initial temperature. Okay? So, if we take 90.5 and we subtract from that 25.2, we get 65.3. Okay, that's a positive change. That means energy is going into the water to heat it up. It takes energy to heat things, to get them hotter, so it's going to be a positive value. So we multiply that by the specific heat, 4.184. Multiply that by the mass, 255, and you get a pretty big number, right? It's a big number. 69,669. So let's round that off. Let's make that 69,700. And then what are the units going to be? What do you expect the units of heat to be? Heat should be joules or kilojoules, right? So let's see if that's true. Grams divided by grams, degrees C divided by degrees C. So you get joules. So there's our answer. But it says put it in kilojoules. Oh, one extra step, right? So this is in joules. We want to put it into kilojoules, okay? Kilos 1,000. So 1 kilojoule is 1,000 joules. So 69,700 joules. And you want to go to kilojoules, so put that in the top. Put 1,000 joules in the bottom. Joules cancel, and you get 69.7 kilojoules. There's the amount of heat required to get water not quite up to its boiling point, right? Boiling point of water at under normal conditions, under normal pressure, would be about 100 degrees C. This is 90, so it's close. It's pretty hot, but not quite to boiling. So there you go.